All right, everybody, welcome back to our series 4, episode 1. Our first podcast ever for our series 4. Welcome, everybody. And also, guys, thank you for joining us today for our podcast today. Also, follow me on TikTok. Join my Discord server right now, y'all. I will put the link in the description below. And guys, we just made 10 subscribers on YouTube. Thank you so much for subscribing my YouTube channel, y'all. We made it. We hit 10 subscribers on YouTube. Thank you for the much support, y'all. Thank you for the support to help me grow on YouTube. Now let's get it to 15 subscribers. Alright, guys. Anyway, so remember last time we talked about how to solve chemical equations and combine different substances. And also we talked about chemical bonds also. So today, guys, we're gonna look at some examples on chemical reactions and also chemical bonds. Chemical equations also we're gonna make. So let's read our description for today. Gonna read our description. Alright. Chemical reactions never lose their balance, and neither should chemical equations. Chemical reactions happen when atoms break chemical bonds and form new ones. And because matter can't be created or destroyed, you always end up with the same amount of matter before and after a chemical reaction. We can represent the inputs and outputs of the reaction with a chemical equation. The inputs should contain the same number of each type of atoms as the outputs. But sometimes you have to do some financing to get these numbers to balance out. It's kind of like solving a puzzle, except these puzzle pieces are particles that make up the whole universe. So, it's like a puzzle, but the puzzle pieces are particles. They're particles. Meaning that the particles that use for the equations is like solving math problems. So, today, we are going to look at some examples today. So, we're going to look at some chemical reactions. Here you go, y'all. Here comes the conversation. We're going to talk about the conversation right now. Again, guys, here we're going to hear the conversation right now. So, again, say multiple times, right? Here we go with the conversation, chemical equations. So, if you take oxygen and hydrogen, for example, on their own, they're gases. And hydrogen is extremely flammable, but they can combine to form water. You probably heard water called H2O. That is a molecule formula. It represents the molecule of water, 2 hydrogen atoms bond to 1 oxygen atom. You see, every element on a periodic table has its own chemical symbol. The symbols usually start with the first letter of the element that represent. O for oxygen, H for hydrogen, Al for aluminum, Ne for neon. Using these symbols, we can write the molecule formula of any known substance in the universe. Like the stuff in your stomach that digests food is called hydrochloric acid, or HCl, meaning 1 hydrogen atom bonded to 1 chlorine. The tops of Jupiter clouds are made of ammonia, or NH3, which represents 1 nitrogen atom combined with 3 hydrogen atoms. But the question is, How did those atoms get together in the first place? That's what chemical equations show. So chemical equations are together bonded into others like hydrogen atoms, oxygen atoms. We discovered a few things. We discovered water is H2O. We discovered that Jupiters are made with ammonia. And we discovered some other stuff from chlorine. So let's try table salt, also known as sodium chloride. It's made of one sodium atom and one chlorine atom. On the left side of the chemical equation, we have our reactants, the substances we're starting with. They react to forms to the products on the right side of the equation. The arrow just shows the direction of the reaction. Pretty simple, but there is one catch. Chlorine atoms naturally occur in bonded pairs. So we cannot just add a single chlorine atom. We can only add a molecule of Ci2. Notice everything off about that chemical equation, alright? Well, you know what? There's a chlorine atom missing. You see, the reactants have 2 chlorine atoms and 1 sodium atom, but the product has only 1 chlorine atom. Since you can destroy or create matter, the equation needs the same amount of each atom on each side. We need to balance the equation by adjusting the numbers in front of the reactants and products. This practice is called stoichiometry, and it's like solving a puzzle. I told you that on the description below when we read it. To go with our pair chlorine atoms, we need 2 sodium atoms. They react to form 2 molecules of salt. Now, it works. Each side of the equation has 2 sodium and 2 chlorines. This ratio, 2 sodium atoms on every chlorine molecule, will be the same no matter how much salt you're making. Unless you know some very fancy algebra, your best bet is to use trial and error until the equation balances out. It can take a while, but it's pretty satisfying once you get it. And that's the end of the chemical equation conversation. Alright, everybody. We are going to do a pop quiz. We're going to review. Starting with question number 1. Which of the following is the chemical reaction? Let's give 20 seconds of this one. Give us a little bit more time. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. The correct answer is number A. Letter A. In the equations shown, what are the reactants? I just told you that. We heard it in the conversation. We can give you 15 seconds for this one. 2H2 plus O2 equals 2H2O. What are the reactants? Five, 4, 3, 2, 1. The answer is hydrogen and oxygen molecules. If you got B right, that's correct. 3. Sulfuric acid is made of 2 hydrogen atoms, which meaning H, 1 sulfur atom, S, and 4 oxygen atoms, O. What is its molecule formula? Ooh, molecule formula. Give you 10 seconds. 5, 4, 3, 2, 1, 0. The answer is C. H2CSO4. It is B. What is the best synonym for word? Alright, here we go. Strychninometry. Sorry for pronouncing. Alright. What is the best synonym for this word right here? Five, 4, 3, 2, 1. B is the correct answer. The chemical symbol Ni most likely represents. Ooh. I will give you 10 seconds for this one. Sorry guys, I was out. Again, the chemical symbol Ni most likely represents carbon, antimony, lead, or nickel. So what is the answer? Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Alright, the correct answer is nickel. 6. How do the products of chemical reactions compare to their reactants? A, B, C, or D? What is the answer? Five, 4, 3, 2, 1. The answer is B. If you said A, you're wrong. B is right. H2 plus O2 equals H2O. What's the problem with the chemical equation shown? There's a problem here about this chemical equation. What is it? Three, 2, 1. The answer is B. There's a missing oxygen in the product. 8. What is the easiest way to balance a chemical equation? We talked about this on a conversation. Five, 4, 3, 2, 1. The answer is trial and error. And it's A. X plus PO4 equals H3PO4. Which reactant is missing from the equation below? Equation shown, I mean. Alright, guys. 5, 4, 3, 2, 1. The answer is 3 hydrogen atoms. Right answer C. Last one. What is the product of the equation shown? 2Na plus S2O3 equals what? What does it equal? Give you a hint, it's not C. A, B, or D. Five, 4, 3, 2, 1. If you say D, you are correct. Alright, guys. This is the end of the podcast. Thank you for watching this podcast, and we will see you guys on the next video and podcast.